Hello everyone, welcome to Azure Developer Community. Today we are back with yet another session relating to Azure Data Services, and today we have our speaker Sagar with us, who has already hosted a session for us on Azure Databricks, I guess. Sagar, right?
Yes.
So today he'll be building up on the things, on the learnings that we had discussed in the previous talk. And as you can see over the screen, today's talk is on Lakehouse architecture and Databricks SQL. So over to you, Sagar.
Yeah. So thanks a lot, Ashivad, and thank very warm welcome to everyone. So as my name is Sagar, and I have total 8+ years of IT experience. I'm currently working on building Azure data and analytics solution for one of the with for one of the client in Europe. This session is a second part of the series of session that we are going to cover for Azure Databricks Lakehouse platform. So in today's session, we are going to talk about Azure Lakehouse architecture and also Databricks SQL Analytics. And at the end, after covering the architecture in Databricks SQL, we'll also look at the live demo on how to work with Databricks notebooks with some live demo. So I hope it will be an informative session for you, and feel free to ask your question whenever you're in between. So let's start with the session. So let's first start with the agenda. So initially, we will cover Azure Databricks Lakehouse platform and architecture. So we will look at how the Azure Databricks platform has been designed from the architecture perspective, the need of this Azure Databricks architecture, and also later on we will look at a few of the best practices which we can follow while working with Databricks Lakehouse platform. After covering the Databricks Lakehouse platform architecture, we will also look at Databricks SQL Analytics. This is basically the new feature which was introduced recently by Databricks. It is in a public preview mode. So, if you are not using premium workspace, then you might not be able to use this feature now. But definitely in future, it can be used. And at the end, we can also pick up some question and answer. Okay. Yeah, so let's start. So first of all, why do we need to understand the architecture? Why it is really important before we can start building data in AI solution using Azure Databricks? We know that in the past, like there were very frequent changes into in terms of data storage while building a cloud solution using any public cloud like Azure, AWS, or also using on-prem resources. So initially, we were building data warehouses. Now with before few years back, when with the introduction of public cloud like Azure and AWS and GCP, enterprise organizations has started moving towards data lakes. So all the data warehouses which they have built, they have also started moving it into cloud data lakes basically. And then recently, in the past few months and years, Azure Databricks and also the open source community has come up with a component called Lakehouse platform, which is basically combining the advantages of both data warehouses and data lake to create a single data solution worldwide. So yeah, nowadays people have started moving towards data lakes to lakehouse. So it is really important to understand how the architecture has evolved, and what is the latest storage solution which we can use to build our data solution using public cloud like Azure and also Databricks. Additionally, like most of the enterprise organizations, while moving to cloud and also implementing data lake and data lake houses, they have faced quite a lot of problem with the quality of data. So sometimes we have created automated data pipelines, but it is not reliable as such. Reliable in the sense the data has been ingested from the source system. It has been moved to the data lake or lake house, but it is missing certain data quality measures, like the formatting is not unique, or certain data is null, etc. So data quality handling is also not very efficient. And as we are living in an era of digital, so we don't only work with tabular data, but we also work with semi-structured and unstructured data. So we deal with multiple images, lot of videos. So in order to consider all this point before you design and implement your data solution, the understanding of architecture is a must. And that's why we will first start with the architecture understanding of Azure Databricks in detail, followed by the best practices of working with Azure Databricks platform. Yeah, so in order to overcome the architectural problem which we discussed few seconds back, uh, what are the features provided by Databricks to overcome those problems? So basically, Databricks helps us to deal with the problem, help us to solve the problem in three categories: the volume of data, variety of data, and velocity of data. So Azure Databricks platform is built on the top of Spark, and it is using Databricks runtime, which is an optimized compute created to work on different workloads like machine learning, data science, or data engineering. So the advantage of using Spark is a distributed programming language, and we can work with we can work with any amount, any amount of data. It can be small, it can also be very large amount of data. Additionally, it also helps us to work with variety of data. So we can work with structured data, semi-structured data, unstructured data, and you can also work with multi-cloud. So now in today's session, we are focusing mainly on Databricks platform, which is built on the top of Azure. But Databricks also has we can also leverage Databricks with public cloud like AWS, GCP, etc. With a click of a button. So you don't have to configure it. And you don't have to spend a lot of manual efforts before you start working on actual application development. You don't have to worry about any proprietary data formats. So as I mentioned, you can work with any type of data, and it is built on it can be built on any data lake. So nowadays in the market, we have Azure Data Lake Storage Gento from Azure, we have AWS S3. You can pick up any of the storage, any of the storage for data lake, but you can work with you can Databricks can work with any of these storage available in the market. And the third problem which Databricks solves is with the velocity. So we can not only work with the batch data, but we can also work with streaming data. And of course, Databricks also has come up with some good inbuilt feature to avoid problems with regulatories and financial risk like GDPR and CCPA compliance, and also supply chain logistics. Yeah, so now after understanding the need of architecture and how Databricks solve the architectural problem at a higher level, now let's look at this diagram. So this is basically a traditional architecture while working with any data solution using any public cloud, or it can be on-prem services. And how Databricks overcome those architectural problem. So in a traditional data solution, basically we have a separate team for data warehousing where data analysts are working open. We have separate team for data engineering, where data engineering are mainly focusing on building end-to-end data pipelines to get the data from the source, do some ETL transformation, and then keep the data ready for the consumers. And there is a dedicated team for data scientists who can work on this data to perform to create a data model and also bring insights for the business. So first of all, in traditional data solution and architecture, all the teams are working in a silos. Since every team are working in a silos, but internally all of them are interrelated with each other. They are basically working in a silos, and which actually decreases the productivity of different team and productivity of a whole solution. Additionally, it is a disconnected system with fixed type of data format, which makes the integration really difficult. So let's say if we talk about data warehousing, we have multiple tools available in the market. We have Redshift from Amazon, we have Azure Synapse, we have Snowflake, we have SAP, we have Teradata, Google BigQuery, IBM DB2, Oracle as well. And let's say Amazon Reds, if you use Teradata, it only supports certain type of format. If you use Google BigQuery, then it has different format. So from the data warehousing perspective, we can build the data warehouse and keep the data, but ideally it becomes really difficult for data engineer to directly consume the data or bring the value out of it. So first of all, they have to do the internal conversion to do it in a compatible format, and then again the same problem can be also faced by the data scientist. Same way, if we talk about data engineering, they basically work with this technology stack. So we have Hadoop, EMR, we have Airflow for the orchestration, we can use Spark, Kafka for real-time streaming, stream analytics from Azure also, and we have TIBCO, Spotfire, etc. And when we look at the data science teams, they also work with multiple tools: Jupyter, Azure ML Studio, MATLAB, SAS, PyTorch. So basically, if we look at the enterprise organization, they are working on a multiple data solution, and they can have a dedicated team for data analysts, data engineers, and data scientists. But they are working in a silos, and let's say some of the data analyst team work with Teradata, some work with Snowflake, then some of the data engineers work with, let's say, Hadoop and EMR, and some data scientists are working with Azure ML Studio and Amazon, let's say, SageMaker. So this, of course, each tool has its own feature, and they come up with their own varieties and features. But ultimately, if the choice of the tool is not consistent, it actually decreases the progress of the actual end-to-end data solution. So basically, this stacks increases the data architecture complexity. So you have to additionally also spend more time doing the data transformation, data cleansing, and data conversion according to the compatible format by different teams. So it takes a lot of time to bring the value out of data, as well as doing those internal conversion can you can also lose some of the value from the data. And also when you operationalize the whole data solution, there are more chances for the failures, and the architecture will become more complex. So in order to solve this problem, and in order to tackle this siloed approach, Databricks came up with a solution where basically all the data related teams like data analysts, data engineers, and data scientists team, they can work together on a single platform without worrying about which type of data, internal conversion that has to be taken care, and what platform or what services has been used by different team members. So this complex architecture can be simplified by using Azure Databricks Lakehouse platform. Yeah, so if we further deep dive into the Azure Databricks Lakehouse architecture and this siloed approach, overall, if you look at the any data solution, then in a siloed approach, basically different team are focusing on their own work. So let's say we have a machine learning team. So their focus is mainly on how they can manage how they can create a machine learning model. Then we have a data engineer team whose main focus is on how they can manage the data for which can be used for machine learning purpose. So data engineering team can focus on configuration to create an automated data pipeline and data collection. Once the configuration and the data collection is done, then comes the machine learning team. So their goal is to use the data which is ingested by the data engineering team, and how they can create an efficient machine learning model, so that it can operate with more accuracy and bring the business insights on the fly, in a near real time. So their goal is to focus on data verification, machine resource management. So let's say For some of the data science model, you need more compute resources, so or you need more, let's say, you have to deal with multiple Python packages and package management. And you also have to use process management tool on how once you create an ML code, how you operationalize it with the help of pickle file, etc. So most of the data science project uses the same library, let's say scikit-learn, XGBoost, Keras, and TensorFlow. But yeah, so Databricks has also inbuilt Databricks runtime, which can easily cater machine learning, let's say, use cases, where all the libraries will be pre-installed and you can directly focus on building the machine learning model. And the third part, which is how you can operationalize the model, basically the MLOps team, where they focus on building the service infrastructure. And once the model is ready, you can deploy the model to the serving infrastructure. And ideally, you should also be able to monitor the performance of the model. And at some point of time, when the threshold reaches, or if the performance is not up to a certain level, then you should be notified immediately. And additionally, whenever the new models are ready, it should be deployed automatically. So with this siloed approach, basically everyone is working on their own track. Data engineers focusing more on how they can manage the data, machine learning engineers are focusing on how they can train the model, and the MLOps team is focusing on how they can productionize the model. But ultimately, at the end, when you want to create a single end-to-end solution, all the team has to collaborate with each other, and there should not be any additional problem like internal conversion or file formatting problem, etc. So in order to solve this siloed approach, Databricks provides a unified and collaborative data and AI lakehouse platform, where every data engineers, data scientists, and data analysts can work together. They can also focus on creating an automated data pipelines with Azure Databricks, with a combination of other Azure services like Data Factory and ADLS Gen 2. Machine learning engineers can also build their high compute Databricks notebook to run the model, and then create an accurate model with more accuracy and more accurate results. And at the same time, Databricks also has closer integration with various Git integrators like GitHub or Azure DevOps, where you can enable continuous integration and continuous deployment for your data solution. And you can also deploy your code to higher environment in a generic way. So this is how you can also, Databricks is a unified platform which can basically cater all type of users to create an end-to-end data analytics and AI solution. Now, after understanding the problem with the traditional architecture, traditional data solution using the traditional services, and now we will deep dive further into the Azure Databricks Lakehouse architecture, how the Databricks Lakehouse platform has been customized on the top of Azure to be leveraged along with other services within Azure like Data Factory, Synapse, and other services. So if you look at this diagram, basically Azure Databricks architecture has two main components: and the Databricks Cloud account, which will be in the background and you won't be able to see it actually, but all the happenings, whenever you work with Databricks, all the internal background activities will be performed here. And this is the customer cloud account. So when you create a resource group in Azure, and when you create a Azure Databricks instance, the Databricks workspace will be created. And from there onwards, you can actually create all the notebooks, create jobs, push the data into DBFS. This will be acting as a front end application for you, and in the background, everything will be taken care by the Databricks cloud account. So in the Databricks cloud account, basically you have a control pane. So in that control pane has Databricks web application, customer notebook, job, queries, and cluster management. So this is basically the control pane, which is managed by the Databricks platform itself in the background. But it is a multi-tenant application. So they using the same web application, customer notebook, job, and queries, and cluster management, they handle all their customers in the background with isolation in place and privacy in place. Now, coming to the customer cloud account, we have a data pane in the customer network. So Yeah, you can deploy your Databricks workspace in a public network or also in a custom VNet or custom bubble network. So you can create a custom VNet inside your company's premise using virtual network and the NSC rules you want. And then you can also, it then can be deployed, but it won't be accessible outside your customer premise. So data plane in the customer network, that is where the front end of the Databricks will be present, where from where you can create multiple notebooks. You can put the data into DBFS. You can create work with SQL as well. You can also create Power BI dashboards and integration with other third-party tools. And whenever you pass on any command, it will basically go to this the Databricks cloud account in the control plane for the execution and take care of the mandatory actions. Additionally, apart from working with user interface in Databricks, you can also use REST API to work with Databricks. So Databricks has multiple inbuilt APIs available. Let's say to create a workspace, to provide a permission, to create, to set up, to configure various security settings in Databricks workspace. They have inbuilt REST API by which so that you can use any programming language like Python, PowerShell, or curl to automate the end-to-end solution creation in multiple environments as well. And additionally, Databricks also has inbuilt integration with Azure Active Directory. So since Azure Active Directory has all the users available for all the enterprise organization, you can easily integrate data Azure Active Directory with Databricks using Scheme. So you don't have to create additional user management and group management within Databricks. So you can use your existing Azure AD group to provide permission to the cluster workspace as well as also for the business user. So let's say if you have a requirement where you only want certain team member from your team to be able to create a Databricks workspace, or create a Databricks cluster, then you can put them into a different group. And you can also create a Azure Active Directory group where to which you only want to provide user to execute the notebook and read only permission. So you can move them to a different AD group, and then you can provide relevant permission and configure it in Databricks, so that the granular level of access management can also be done, is also possible within Databricks with Azure AD integration and also single sign-on. So with the same user ID and password by which you log in into your Azure account, Azure portal, you can also continue accessing the Databricks and then start work building your data and AI solution. So this is the overall architecture of how Databricks has been customized on the top of Azure to work with to provision the Azure Databricks workspace, and how it can easily integrate with other available Azure services like Data Factory, Synapse, etc. So moving on to the next slide. After understanding the basic architecture and high-level working of how Azure Databricks work in the combination with the Databricks Cloud account, now we will further deep dive into the technologies that Databricks provides. So basically, as I mentioned, Azure Databricks is available as an inbuilt service in Azure Marketplace. So it has full integration with other Azure services like Data Lake Storage Gen 2, Azure Data Factory, Azure SQL Database, Azure PostgreSQL, etc. So from different type of sources, basically you can get the data. So you have, let's say, SQL DB from where you want to move the data into somewhere into DBFS to perform machine learning, to create a machine learning model and generate Power BI reports. So the whole chain can be followed in this manner. So from SQL DB or ADLS Gen 2 is acting as a data source from where we can basically create an ETL data processing pipelines in Databricks using multiple. There are multiple languages in which we can write a code in Databricks. So you can use R, Python, Java, or you can also use SQL. But Python is more preferable. Python is more preferred to create those automated ETL pipelines. So this is the standard architecture that has been followed for most of the Databricks implementation, where there are like three zones: bronze, silver, and gold. So you first get the data from the source and move it into bronze. You perform the data transformation and data cleansing on the top of data that you have in bronze and move it into the silver zone. And from the silver zone, you basically integrate and merge multiple data sources that can be consumed directly by the business users from the gold zone. So we can create an automated ETL data pipelines using Databricks as well as certain open source technologies like Databricks Delta, where you can continuously move batch and real time data from the data source to multiple zones. And for your business consumers, the data will be available in a very less amount of time for to consume the data and then generates more insight. Now coming back to the unified analytics platform from Databricks, we have multiple components which can be used. So Databricks has notebooks where you can write your code in Python, Java, R, or SQL. You can create machine learning model, so it you can choose multiple Databricks runtime as per your convenience, where a lot of pre-installed machine learning libraries are available. So you can start building the model and do the model testing and validation as well. You can use APIs to automate the configuration creation as well as running the notebook via some front end application. And if you want to schedule, if you once you operationalize your notebooks and your data solution, if you want to schedule those pipelines automatically, then you can also use jobs, or you can also integrate it with Azure Data Factory as an orchestrator to use the features of let's say event triggering or blob triggering, etc. Additionally, the Databricks platform also has closer integration with BI tools like Tableau, Power BI, where you can create interactive Power BI dashboards, Power BI reports, and then that can be presented directly to the business users. So let's say you have a data engineering team who has access to certain notebooks where they can work on building automated data pipeline in ETL pipelines. Yeah, and then you have a machine learning team. They can also work on the same workspace. They can focus on data modeling, and then once you create a report and dashboards, you can publish those reports to the business users, and they can also work with the same Databricks workspace. But none of the team, let's say data engineering team, cannot access the artifacts from data science team, and business teams cannot access the notebook that we have in Databricks. So this granular level of isolation and access can also be done, and it can be managed by Databricks administrator. And as I mentioned, the underlying compute when we work with Databricks is we have to create a Databricks cluster, and in the cluster you have to select the Databricks runtime. So Databricks has multiple Databricks runtime available with different version of Spark, along with various pre-installed ML libraries. So you can based on your workload, you can actually select the optimized Databricks runtime to also control the cost for your Databricks workspace. Then once the development part is done, basically now next part is to operationalize the data solution somewhere on Azure or on a containerized or Kubernetes platform. From where we can like business users can track the result, and they can also get access to the final outcome or business insights. So basically as we can deploy the data solution on Docker or Azure Kubernetes, and then we can also do the continuous monitoring to check if the performance is okay or not. We can so on the fly we can ingest the data, we can perform the data modeling, data transformation, and also generate the report in near real time in Power BI or Tableau. And additionally, Azure Databricks also has closer integration with MLflow. MLflow is an open source project where it has mainly four major components: MLflow tracking, MLflow projects, MLflow models, and MLflow repositories. So with MLflow tracking, you can track the model performance in a near real time. In MLflow projects and repositories, you can maintain all your codes about MLflow, and in MLflow model you can basically maintain the versioning of different ML models. So it is a single package where you can fully store and also track all your machine learning workloads, which can be leveraged at a later point of time, and it will also help you to operationalize more and more models in the production. Okay, So this is more about the Databricks Lakehouse architecture at a higher level, and now since the session is more about how we can productionize and operationalize Databricks solution on Azure, and let's look at the architecture using Azure services, how we can operationalize, how we can create and operationalize data solution on using Azure Databricks. So from the sourcing perspective, yeah, I think as you are most of you are aware, we can have a multiple type of data sources. We can have a structured data sources. We can have unstructured data sources, and we can also have a near real time data sources from sensors and IoT. So based on the type of data that we are dealing with and the pattern, batch or near real time, we can use data factory for the batch type of data, and we can use event hub or IoT hub Kafka to get the data in a near real time from sensors and IoT. So we can ingest data using services like Azure Data Factory, which is acting as an orchestrator, and which will basically move the data from the data different data sources to the storage services like Azure Data Lake Storage. Now in Azure Data Lake Storage, ideally we can in Azure Data Lake Storage, ideally we can store data in the raw format. But if we integrate it with Azure Databricks, then we can also store the data in a delta format where we can perform ACID transaction operations as well. So once the data is available from the source and moved via ETL pipeline into the storage services like Azure Data Lake Storage, we there comes Azure Databricks, where we can write a logic to create data pipelines. We can also do data cleansing and data preparation as well, data profiling. And for machine learning part, we can create a machine learning model and also train and test and validate the model. And then once the preparation data transformation is done and data is ready to be consumed by the ML team, then basically you can operationalize the model for the model serving in a service like Azure Kubernetes service, or also you can move the data into operational databases like Azure SQL DB or Cosmos DB, from where your business team can directly connect to those databases and create a Power BI dashboards for the insights, or your machine learning model can create an intelligent actions to, let's say, increase your business, etc. So this way you can fully create an end-to-end chain using Azure Databricks and integration with other Azure services. So you don't have to do any additional configuration. The integration of other Azure services like Data Factory, Event Hub, Kafka, IoT is by default available with Databricks. So with few line of code and with proper and correct settings, you can basically connect with different services, and it can be acting as a unified platform for your data engineers, data analysts, as well as data scientists. Now this is like another view, but it's more in terms of security and how while working with with a private and sensitive data, how you should architect and design your Databricks solution you on Azure. So as we have already seen in the last few slides, Azure Databricks has closer integration with services like Event Hub, Data Factory, etc. But as we as we discussed at the beginning of this session, Databricks can be deployed in two ways. So you can deploy Databricks in a public network, which will be hosted somewhere in the Databricks cloud, and then you can use it. Or you can also create your own custom VNet and then deploy your Databricks in a custom VNet. So the second solution is more preferable, where you can create your own custom VNet, because in this custom VNet you have to create two subnets, ADB public and ADB private, and all the services to which you want to connect from Databricks, you can define the required NSC rules into the NS network security group rules. And so the connectivity from Databricks to other services will be very limited, as well as there is no risk of losing any sensitive data, or it can be accessible by other teams without you do any additional setup. So deploying the Databricks workspace in a custom VNet is a more preferable way to is a more preferable way to deploy and work with Databricks to build the data solution. And of course, it has also integration with services like SQL DB, Data Lake, and Synapse, from where you can store the data and create more insights. Yeah, so after understanding the architecture now, yeah, we have looked at the evolution of the data solution architecture, starting from data warehouses to data lake and data lakehouse platform. So if you want to create a modern data warehouse on the top of Azure, then this can be the standard pattern, which can be which is basically followed by most of the enterprise organization. So from the different sources, you get the data. You basically get the data. So in Data Factory, you have a trigger available. So there are multiple types of triggers available in Data Factory. So if you want to trigger your data pipeline as soon as the data arrives, then you can use event trigger option. So as soon as any data arrives, using ETL pipelines, we can move the data into data lake storage. And whenever there is a data available in any of the containers, then we using event trigger, it will trigger the Data Factory pipeline, which will basically acting as an orchestrator, which has activities like Databricks Notebook, Synapse, and Azure Analysis Service. So in Data Factory Orchestrator, it will execute the Databricks notebook, in which we can write a logic for ETL transformation, as well as machine learning model creation, validation, and testing and verification. And then Azure Synapse to perform the transformation on the top of result that we create and aggregate it. And then we can create a model in Azure Analysis Service, and that will be have a closer integration with Power BI to do the visualization in a near real time. So this is the standard way by which we can also implement modern data warehouses implementation on Azure and using Azure Databricks. So yeah, this is also like high level architecture, how we can basically combine multiple component and create a secure solution using custom VNet and Azure Databricks, and also in a combination of multiple services with different configuration. Uh, Now, after understanding the overall architecture of building Azure Databricks solution and its component, there are also few accelerators available by default by Databricks platform, using open source technologies, which will actually help us to accelerate our journey of building data and AI solution on Azure, and also operationalizing the same. So one of the open source technology that Databricks has available is Delta Lake. So Delta Lake is an open source technology, but it is being actively driven by Databricks company, and you can basically create a Delta Lake. You can also do ACID transaction with the help of Delta Lake, and it is a combination of data as well as metadata in a open source Parquet format. So using autoloader or any of the batch pipeline, you can basically load the data into load the data from different sources, and then create a delta lake by maintaining this type of zones like indecent table, in a bronze, a refined table, and aggregated table. And once the data is available in data lake, it can be consumed by machine learning teams as well as business intelligence team to create visualization reports. Uh, yeah, so now we will also check in detail like how we can operationalize the end-to-end solution for an enterprise organization, with proper monitoring and deployment of with starting from developing the application, then deploying the application to production, and once the application is productionized, then how we can basically proactively monitor the performance, as well as integration with other services, for let's say integration with Azure Purview to create an end-to-end horizontal and vertical lineage integration with DevOps for CI/CD implementation, etc. So this is how the high level architecture looks like. So we start from the bottom. So these are the services which are used across multiple phase during the implementation of this Databricks Lakehouse architecture. So we have Azure Purview. So it is this tool has been recently introduced by Microsoft couple of months back, where it will help you to create and build end-to-end lineage solution using Azure services basically. So let's say when we talk about lineage, then let's say you got data from source A, you have performed certain operation, and at the end you have stored the data in a way that can be consumed by the business users. But from the regulatory perspective, all the data transformation has to be tracked in a certain visualized format, so that they can make sure that no sensitive data has been exposed to the unauthorized user. So if you use inbuilt data Azure services along with Azure Purview, then you can collect all the data, and it has inbuilt feature to create those lineage and visualization. So all the activities that we perform in Data Factory as well as also in Databricks will be tracked, and it will be the lineage will be created out of the box. Then CI/CD. So in order to uh, accelerate the development activity and time to market release, it is really mandatory to implement Azure DevOps and CI/CD implementation, as well as also deploying the application to higher environment in a generic way. So even Databricks has a closer integration with DevOps, where once your code is ready and tested, it will be deployed automatically to higher environment based on the configured pipeline and the settings with Azure DevOps Git integration. Then Azure Keyword. So yes, as we know, we have to deal with we can actually use data lake storage, and you want to connect to data lake storage from Databricks. So in order to do that, you have to use storage account key or various other sensitive information. So Databricks also has integration with Keyword, where you can use Azure Keyword back Databricks secret scope. So without exposing secrets inside your Databricks notebook, you can use secret scope, which is backed up from the Keyword, and then you can configure it to connect to the multiple sources and get the data. Azure Active Directory for single sign-on and permission management at various level. Azure Monitor. So once your model is operationalized, you can integrate it with Azure Monitor to receive proactive alerts, as well as also you can monitor the performance of the model, and if certain configuration changes are required, that can be done. And cost management and billing as well. So Azure has inbuilt feature, Azure Cost Advisor and Cost Management and Billing, where we also have to track the cost, because that is the advantage of using cloud. So using tags in Databricks and integration with Azure Cost Management and Billing, we can also do some kind of proactive monitoring on the from the cost perspective, and then we can reduce the cost of our end-to-end data solution. So yeah, for ingesting the data, we can use Data Factory for batch data, as well as Azure Event Hub to get the data in a near real time. Then we have a Databricks, which basically follows the standard architecture to get the data into bronze layer, then move it into silver, and then aggregate them into the gold layer, so that end users or business users can use it. So business users or end users can be a machine learning model, where they can create a model and it will be running on Azure Kubernetes. It can be data analyst, where on the top of data that we have available in the gold zone, they create the reports, and then you will get business insights in a visualized manner for business stakeholders, and it can also be integrated with Azure Synapse. So this is how we can closely collaborate and integrate other Azure services with Azure Databricks to create your end-to-end data solution. Then yeah, this is another pattern. So in this pattern, in a generic way, we covered how we can create a batch and near real-time pattern. But as I mentioned earlier, we also have Delta Lake, which is an open source format to store the data, and it has its own benefit. So this is another pattern. If you want to implement Delta Lake pattern with Databricks, then we can follow this approach. And we starting from getting the data, ingesting it into the landing into the storage of Azure, and then performing the data transformation and maintaining the version history with Delta Lake, and followed by creating a Power BI reports as well as machine learning model. So this pattern can be followed if you want to implement Delta Lake with Azure Databricks. Yeah, so after understanding the architecture, let's also go through a few recommended practices from the architecture perspective in order to work with different components, like for ingestion, or how to integrate it with DevOps, or how to create a Power BI dashboard in a near real time. So the first one is autoloader. So a Databricks has inbuilt feature to load the new data efficiently as it arrives into the cloud storage. So before the introduction of this autoloader feature, you have to you have to create this complex architecture basically. But now with the autoloader feature, it is very easy. So from the data sources, you can create a pipeline to move the data directly to the data sources. So it is much easier. Then under the hood, autoloader works like this. So of course we don't have to worry about it, but if we write one line of code using autoloader to load the data from different sources, in the background it has this cloud storage which has notification and message queue. Then it will move the data in a delta lake format. So this will be the underlying under the hood working of autoloader. Then integration of apps, Azure Databricks with other services. So Databricks has closer integration with various services like Data Factory, SQL DB, Synapse, Storage, Cosmos DB, and also it has connector for different external connectors like Amazon S3, SAP HANA, at DFS. You can also work with generic protocols. So it has more than 300 plus external connector, which can be used directly without any additional configuration and in a plug and play manner. Then scheduling. So ideally, we use Databricks to perform the deployment and do the development activities. But in order to once your data solution is ready, you have to schedule your solution. So it has inbuilt job, and it also has a closer integration with Apache Airflow and Data Factory, where you can schedule your data solution so that you can automatically perform the data ingestion as well as bring the insights for the business. Then Delta Live Table. So this is also the new feature which is currently in public preview mode, and it simplifies the full ETL life cycle and improve the operational agility. So we can create Delta Live Table to declarative to build and test the pipeline with end-to-end visibilities. We can create a reliable data with a lot of data quality inbuilt features available, and then you can also do the scalable operations by automating the deployment, monitoring, and recovery in case required in production. Yeah, so ideally, if you look at any ETL, basically, if you want to create any ETL pipeline for batch pattern with Databricks, then this is the format that most of the enterprise organizations follow. So, get the data from different sources in a row format, put it into the bronze zone, that is called as a row ingestion zone. From the bronze zone, do all the data transformation, data cleansing, data quality check, and read the data and put it into silver zone. And once it is available in the silver zone, you can basically aggregate the data based on your business requirement so that it can be directly consumed by the business users. Then the major really important part is data ops on Databricks. So as we said, Databricks is a platform where data scientists, data engineers, and machine learning engineers can work together to work on their separate solutions. So data ops is really required in order to fully accelerate the journey of developing the data solution as well as deploying in a near real time. So Databricks has closer integration with various grid providers like Bitbucket, GitHub, as well as Azure DevOps. So in the source stage, developer commit the changes, and then once you integrate it with Git repositories like DevOps or Bitbucket, you can build the code which will be in which you can perform automated testing. And once the testing is successful, you can deploy the code from development environment to test acceptance, and then also to prod with some pre-verification in place. So the advantage of this Git integration is that you can implement continuous integration and continuous delivery. So you can develop code, you can do the build and continuous testing as well. And once testing is successful, you can the release will be triggered automatically to deploy the notebooks into the higher environment. And also by this way, you can operationalize your major release or changes in a very quick and efficient manner. The key benefits of continuous integration is that regressions are captured because we have automated tests implemented. You don't have to take any additional action once your code is developed. The building the release is very easy, and you don't have to take any manual action. So once the build integration is done and successful, the release pipeline will be triggered automatically, which will deploy the code to higher environment. And the testing, even your QA team has to spend less time on testing and focusing more on the overall quality culture. So this is how the overall kind of design looks like, where you do the local development using Databricks CLI or integration with Databricks. You import and export the notebooks and other required data into the development environment. Then once you integrate it with Azure DevOps, you can create a master branch, like using a pull request. Your all the local changes will be committed to the master branch, and then once it is available in the master branch, the continuous integration pipeline will download the artifacts, perform all the automated testing, and then deploy the code to higher environments. Now the second topic is regarding Databricks SQL Analytics. So this is also the new feature which was recently announced by Databricks team a couple of months back. It is still in a public preview mode. So you might not be able to access it until and unless it is released for your Databricks premium workspace. So Databricks SQL Analytics run is used to run quick ad hoc SQL queries on the top of data lake, and these queries can also support multiple visualization type to explore the query results. So as I mentioned earlier, Databricks we can work with Py.
Sorry for the interruption, guys. Let's wait for a minute. Sagar will be coming back. In the meanwhile, Sagar comes back, you can have a look at all the upcoming events that we have. So we have a session on virtual reality and mixed reality lined up tomorrow from 5:30 p.m. to 7 p.m. There's one on Azure Cognitive Services, Speech API. There are a plethora of events. So there's one from machine learning pipelines in Azure ML. Then there's Prometheus and Grafana on Azure. What is a SARI? If you're looking into a DevOps kind of a role and you wanted to know what it is and how can Azure help you, then go check out the session. And there's a lot more. You can also go and search for the nearest Azure developer community that's there near you and go and join there to stay updated. So we have a lot of cities. You can go to our website, azdev.community, and just join any of our communities that are near to you. We have a lot of partner communities that we have, and you can get a history of everything. These are all our community organizers and some of the registered speakers. So do check out all the events. And Sagar is back, so let's get started.
Yeah, thanks a lot, Asirvad, and I'm really sorry for the trouble.
No worries, no worries. It does
So
happen.
yeah, so are you guys able to see my screen?
Yes.
Okay, perfect. So let me start again. So yeah, we were talking about Azure Databricks SQL Analytics. So it is an recently introduced feature by Databricks, and it will allow you to run the quick ad hoc SQL queries on top of data lake or delta lake, which you have built on the top of DBFS or Databricks. So the features are as follows. It has fully managed SQL endpoints in the keyword. You can also create interactive dashboards for sharing the insights. You can also create alerts to help you to monitor and integrate. It has enterprise security because it has integration with Azure AD as well. It has integration with other Azure services, including Power BI. So, as I mentioned, this feature is in a public preview mode, but once it is available, it is now only available for premium workspace. This is how the front page of the Databricks SQL Analytics looks like. So, from the Databricks homepage, when you select Databricks SQL, you will be able to see this front page, and then you can basically work with SQL Query Editor. You can there are also various sample dashboards available, and you can also work with sample data and connect to the preferred BI tool like Tableau, Power BI, and there are also few more BI tools available. So this is one of the sample report available in Databricks SQL workspace. So this way you can create very fancy and interactive dashboards, and in the background you can continuously update the data with your ETL pipelines, and these dashboards will be up to date, and you can get more insights with a click of a button and in a single dashboard or a single report. So if you want to work with SQL queries, yeah, you can go to the query editor from the Databricks SQL option, and then you can write all different type of SQL queries to create a result in a way you want to do, and then you can integrate it with BI tools like Tableau, Power BI, or other BI services. Then coming back to a few of the concepts of Databricks SQL Analytics. So you have Databricks user interface, which we have seen a few slides back. So from the user interface, you can work with queries, SQL endpoints, query history, as well as alerts. Data management. So you have basically visualization and dashboard where you can create interactive reports and dashboard, and you can also create an alert to you can get a notification on the fly when certain threshold reaches with the data that you have incorporated and monitored in the Power BI report or any other tool report in the tool. Computation management query. Where you can write your any valid SQL statement and it will be executed. You don't have to install any other thing. SQL endpoint. So computation, it is a computation resource on which we can run the and execute the SQL queries. Query history. So all the query that we run in the query editor, all the histories will be maintained. And with respect to security, it has proper authentication and authorization. So it has closer integration with Azure AD, and you can create users and group so that you can manage it efficiently. You don't have to provide permission at a user level. You can create a personal access token which has certain permission, and you can also use it for your automation and access control list. So even within the same workspace and same Databricks SQL, if you want to isolate the permission between different group of members, then you can implement access control list to a certain group so that they can have a granular level of access while working with Databricks SQL Analytics. Yeah. So I think that's what I wanted to share about Databricks SQL Analytics, and let's also deep dive a bit more into from the hands-on perspective. Yeah, for the benefit of time, I'll be a little bit fast. So we will scroll through few notebooks and also execute them. Uh, Yep. So basically, the first example that we are going to see is about gentle introduction of how to work with Apache Spark on Databricks. So this is the Databricks instance. So this is the Databricks instance, which is so this is basically the Databricks instance where the cluster is already ready and workspace is also there. So I will just start the cluster once. So I go to the compute development, and yeah, so from here we can start the cluster. Yeah, so if you look at this notebook, basically you can write this is a Python notebook. So if you write Spark, then you will get information about the version of the Spark and the master, the details about app node and the master, etc. Then this is how you can basically write a Spark code. So here we are trying to retrieve the range of values from 0 to this value. And then coming back to the transformation and action, so there are multiple type of transformation and actions available in the Spark. So we can basically use any one of this type of transformation or action, and then do the data transformation with Databricks. And then this is more about architecture. And yeah, the if you look at the output, let's say here we are trying to display the output of the data frame which you created in the previous cell. There are multiple options available. So if you click on this, then it will basically display the output as a bar chart. So here it displays the output as a data frame and as a table, but you can also display it as a bar chart. And you can basically select different type of you can use different plot options as well. So Databricks is an inbuilt, basically unified analytics tool where we can do data ingestion, data cleansing, data transformation, as well as once the data is ready, you can also visualize it with its inbuilt collector with various visualization tool like Power BI, etc. So I think, yeah, that's it for the demo from my side. So any questions? If no, then over to you, Asirvad.
Sure, Sagar. It has been a great session. Thank you for taking some time out of your busy schedule. I know it's a working day. It'll be difficult for you, to manage it. I totally understand it. And, let's see if we do get any questions. So if you don't get any in the next 1 minute, we can call it a wrap for the day.
Yeah,
In the
sure.
meanwhile, you can share any resources that you would like to share with our audiences, so that they can refer to after the session and go through some of the concepts that you discussed today.
Yeah, yeah, sure.
Okay, we haven't got any questions. So, Sagar, are you sharing the links?
Yes, I have just set the link for Databrick SQL.
Okay.
And yeah.
I'm passing on the links in the chat window. You people can take it out from there and explore about the topic a bit more on the links.
Yeah.
Yeah. So I think that's all from our side. Thank you, Sagar, for joining in, and thank you everyone for joining on. Okay, we have a question by Purna Chandra. So it's, what is the difference between Azure Databricks and Dataflow? Which one is cost effective?
Yeah, I think yes. So Databricks, as I mentioned, it is a unified analytics tool where we can do all the data cleansing, data transformation, as well as connecting with various visualization tool. But data flow is a component available in data factory. It also has various inbuilt basically GUI drag and drop transformations available. So from with respect to cost, if you are working with your data solution on Azure, then
Sorry.
Azure data flow is cheaper than Azure Databricks. But in data flow you have some limitations. It has like multiple drag and drop activities available. But in Databricks, basically, it has also very close integration with other machine learning packages and tool as well. So in data from the comfort perspective, Databricks is preferred, but from the cost perspective, data flow is cheaper than Databricks.
I hope it answers Purna. So let's wait for any more questions since we got in the last second. Let's wait for a minute. If we don't, then we'll call it a wrap.
Yeah.
Mhm. Okay, guys. So Sagar has shared some of the links which I've shared in the chat window. You can have a look at that if you wanted to explore this area or topic more. So since there's no more question in the chat window, let's call it a day. And take care. Have a good day. Stay safe. And meet you all tomorrow. There's another session. Do join in for that. And bye bye.
Okay, thank you. Bye.